In question 5, we are kicking off with a question on non-right-angled trigonometry. We're given this triangle with AB equals 100 meters, BC 50 meters, and angle ACB 43.7. We're asked to show that the size of angle BAC, which is this angle here, is equal to 20.2. Correct, 3 significant figures. So the key thing to notice here then is that essentially we have got two pairs of information. We have got an angle and the side opposite. And here we have got the side and we're trying to find the angle opposite. So here we're going to use the sine rule. We want to have the unknown at the top, which is the angle. So the version of the formula we're going to use is sine 43.7, which is the angle we've got, divided by the length of the side opposite. So that ratio is constant in this triangle. So if we have sine theta divided by the sine opposite, that will have the same value. So we can rearrange that to work out that sine theta is going to equal sine 43.7 over 100 times 50, which is going to give us 0.345. However, that is sine theta. So we need to do inverse sine theta, 0.345, which gives us an answer of 20.2 degrees, correct to 3 significant figures. Part B asks us to calculate the area of triangle ABC. Now, we don't have the perpendicular height here, so we're going to have to use the area of a triangle using trig. So the formula for the area of a triangle using trig is half AB sine C. Now, obviously, here we've got a triangle labelled A, B, and C, so it can all get a little bit complicated. Remember, when we're looking at the formula for the area of a triangle using trig, the A and the B are the two sides that sandwich the angle. Now, you can see in this diagram, in this triangle ABC, the two sides we've got are here, this length here, which is 100, and this length here, which is 50. So when we talk about half AB, those are the two sides we have. So that's going to be half times, and it doesn't matter which way around they go, so 100 times 50 or 50 times 100, it's the same thing, multiplied by the sine of the angle in between them. Now, at the moment, we don't have that angle. Now, we can obviously work that out by just doing 180 minus 43.7 minus 20.2, and we end up with an answer for this angle of 116.1. So this angle, the angle in between the two lengths, is going to be what we want, so sine 116.1. If we work that out, we get an answer of 2,245 meters squared. In part C, we're asked to find the length AC. Now, again, we can identify two pairs here. So we've got this angle here, 20.2, and the side opposite it, and we've got 116.1. We're being asked to find the side opposite it. So the easiest way to work this out is to use the sine rule. And again, keeping the unknown at the top, which this time is going to be the length. So we're going to have AC divided by the sine of the angle opposite it, which is 116.1. That ratio is going to be the same as 50 divided by the sine of the angle opposite it, which is 20.2. So therefore, AC is going to equal 50 divided by sine 20.2 multiplied by sine 116.1, and if we work that out, that gives us an answer of 130, correct, 3 significant figures. Now, because we've actually got side, angle, side, we could use the cosine rule here as well, but personally I think the sine rule is a lot easier to work out a length AC. Part D proved the real quiz in this question, and it was answered correctly by only very few pupils. We've got a vertical pole, TB, which is marked here, which we know is 25 meters, and we're asked to calculate the angle of elevation of that point T from M, which is the midpoint here on the line AC. So what I've tried to do over here is just abstract out this little triangle here. So we've got MB, which I've marked on there, so we don't have that length. We've got MT, this blue line here, which I've marked on here. So this angle here, theta, is the angle of elevation that we're trying to work out. And we've got the height of the pole, which we know is 25 meters. So I've marked on the height there, 25 meters. So at the moment, we can't work that out. So we need to figure out how we can actually work out the angle of elevation. And we need to start by looking at the additional information we've got. So if we look at triangle MBC over here, in the previous question, we already worked out the length of AC. So we worked out the length of AC was 130. Therefore, MC, from the midpoint to the end, must be half of that, which is 65. So again, now we've got side, angle, side. Whenever we see side, angle, side like that, we can use the cosine rule to work out the missing side BM. So we can say that BM squared is going to be, again, it doesn't matter which way around the two sides go. Remember the cosine rules, A squared equals B squared plus C squared minus 2BC cos A. So that means the B squared is one of the sides. So if we do BM squared, we've got, let's say, 50 squared plus the other side, which sandwiches the angle, which is 65 squared, minus 2 times BC, which is going to be 50 times 65, multiplied by cos of the angle in between them, which is going to be 43.7. That is going to give us an answer of 2025.7, but that is BM squared, so therefore BM is going to be the square root of that, which gives us an answer of 45 meters. So if we go back to our triangle up here, we can put in 45 as the distance MB. And then it's just a case of recognizing that relative to the angle, we have got the opposite and the adjacent. Therefore, we're going to use tan. So tan theta equals opposite over adjacent, 25 over 45, which gives us 0.5 recurring. So therefore, theta is going to be inverse tan 0.5 recurring, which gives us an answer of 29.1 degrees to three significant figure for the angle of elevation of T from M.